Hello there, and a very, very warm welcome to all of you. We're absolutely delighted that you've taken the time to join us. It's a very, very special webinar. Of course, we're back with you, harnessing green hydrogen for secure and affordable energy. This is absolutely essential. And we look at items like this. And of course, here we are with Refinitiv, supported by the Al-Attiyah Foundation, bringing you these webinars. So we're delighted you take the time to join us. And it's a tremendous series, and we've been getting great feedback from you. So we really want to make sure that you're involved today. And we've got a great lineup of panelists and experts for you. I'm Etna Trainer. I'm going to be the moderator for this whole session. Now, of course, the Al-Attiyah Foundation, when we look at the great work that's going on from that think tank, really put in place to be looking at relevant, robust, and indeed practical knowledge in terms of energy and looking at a sustainable future. So, of course, we're beginning to hear a lot about hydrogen. And hydrogen is nothing new, of course, in the industry. But when we look at its application, I suppose, in terms of the mainstream and its presence and its importance, perhaps, in the energy transition and the future of what the energy transition is going to be, this is what's a very, very exciting development. And my panel is very excited about this, very knowledgeable about it, and they'll be able to bring us up to date with what they see is happening and where they see the future is in terms of productivity, in terms of investment, in terms of policy, in terms of what we need to do to make sure that green hydrogen is right up there on the agenda when it comes to governments, when it comes to investors. So a lot at stake here. At the moment, yes, lots of hydrogen around, possibly 70 million tons right now produced annually, but and used in a variety of applications, of course, oil refinery, ammonia, methanol production, food processing, metal processing, transportation, and power generation, of course. So a lot of this, and about 95% of this at the moment, is produced from hydrocarbons. So there's an emission problem, of course, and everybody is really looking at how to reduce emissions right now. So this is one area that we have to really look at, hydrogen as a solution, but clean and green hydrogen perhaps as the best solution to make sure that we actually get it on. So the race is on, it's beginning to happen, and I have three great experts in place. I'm delighted they're with us. So let me quickly introduce you to them, and then we're going to go and we will have a quick presentation, and then the introductory presentation, and we'll get right down to business. So I'd like to introduce you to the Senior Vice President for Argus Consulting for Asia and the Middle East. He is Yo Yu King, and we're going to hear for a presentation from him very, very shortly. Professor David Hart is with us also. He's the Director of E4 Tech, and we're delighted that he's here, and also works actually at Imperial College in London. So a lot on the academic side too. He has huge experience behind. We're really looking forward to getting more detail from him, and also from Nel Hydrogen, the Senior Vice President, also Philip Schmidt from the electrolysis division too. So there are three lineups, but let's first, if I could go to you, Kin, and ask for your introductory presentation.
Thank you very much for inviting me to this webinar. I'm delighted to participate in the discussion of this potentially new carbon-free energy carrier that has caught the attention and excitement of many energy participants. Okay, so these are as follows. One, just talk about global CO2 emissions and climate change. Number two is why is green hydrogen in focus recently, and what are the major challenges, and finally, how far are we at this hydrogen economy? So let me just very quickly go to the first slide, really just to talk about global warming and CO2. It's no surprising that over the last 50 years, the emissions have expanded or accelerated, and only major economic disruptions has managed to slow down this growth or reverse it in some way. So COVID-19 pandemic has managed to reduce the CO2 emissions by about 15 to 20% in the height of the government lockdown in May and April this year. So it just demonstrates how difficult it is to reduce global CO2 emissions, and therefore a substitute or alternative carbon-free energy source is required. So why has this now become so much in focus? One reason I can think of is basically the rapid development of renewable energy. So, as you know, renewable energy costs has reduced significantly over the last 3 years. If you can see the graph on the right, especially for solar power. So LCE for wind and solar power recent years have consistently fallen below that of coal and CCGT. So wind and solar is now considered mature technologies in both developed and developing countries. And installation has also accelerated in both absolute terms and also as a percentage of total power generation. Much as this may be, if you look at the next slide, is that while the acceleration of renewable energy deployment, it is not done evenly. So the map on the left, you can see two maps. One is showing wind and solar power concentration by country in 2019. Green hydrogen market, when developed, has the potential to enable energy generation in places with high concentration of high wind and solar resources and then export them into energy where a key demand centers. It may also unlock blue energy and prolong the contribution of fossil fuel in the global energy mix. So what's the issue? I think the primary challenge to achieving a hydrogen economy is really cost. So Argus really estimates the current cost to produce, to transform, to liberate, and to transport green hydrogen through a seaborne market ranges between $6 to $8 US a kilo. Translate that in energy terms, you're talking about $45 to $65 US per MMBTU. So that's significantly higher than natural gas. In times, that may reduce, but only if there's a rapidly developing market that allows selected technologies and or certain type of transportation route to achieve economies of scale and therefore bring down the cost. So finally, how far are we away from developing the hydrogen economy? Hydrogen currently development is in many ways equivalent to LNG about 50 years ago. So you can see the graph on the left that in 1969 there was the first LNG shipment. So it will probably take bold steps in developing this into an active market. So how long this will take really is hard to say. But it really depends on developing the necessary critical mass to produce, to consume, and also transport infrastructure, and also setting a common standard. Thank you.
And indeed, thank you so much for that very matter-of-fact, direct, and short presentation. It sets the scene really nicely for us. Now, I'd like to get everybody involved at home. And if you can just keep an eye on your screen there, we're going to put up our first poll. So we have lots to talk about, but I'd love to get, a feeling in terms of what the feeling is out there among you when you're looking at this and think, when we look at it, what area of the hydrogen economy should government prioritize? Because it's definitely on the agenda and they're looking at it and there is money to be found. So have a vote on that there, and we're going to then come back and have a look. So I hope you can all see that. And you pulled up that polling question there. So let's have a look and see. Our polling should be closed at this point, and I should be getting a result very, very quickly here. And indeed we have. And we're not surprised that it is probably, it's a nice demonstration of kind of, I think, we're being very democratic here. 25% on just get it done, get the production in place. Priorities 24% and 22% on industry. There, so it's domestic heating. Nobody's worried about that one. Okay, so let me come to Professor David Hart on that. And David, let me talk to you in terms of, obviously we've got to get this started. I suppose it has been started, but it's taken quite a long time to actually get to this point. So give us your opinion in terms of, okay, what other people are thinking, and perhaps how does your thinking match up, David?
So thank you, Attiyah, and thank you everybody for the organisation of this webinar, which I agree is exciting and timely. So looking at that poll, I think it represents a very helpful background, which is that hydrogen, as Yukin said, fits into every part of the energy system. And it's actually, I think, important that we don't prioritize a single area. What we need to do is identify two main things. We need to identify large-scale opportunities where we can bring costs down by putting in place significant industrial production and industrial end use. And we need to identify small-scale opportunities which start to put hydrogen technologies into place in communities, in areas where the economics actually work well. And those are very often in perhaps remote communities, islanded communities, where you may be paying already more for your energy. There are two big areas of focus which are quite tangentially opposed. One is very large, one is very small. But within that, there are many, many different things we can do, which are on the production side, on the transportation side, on end use. And I think we're going to see development in all of the above, which is going to be driving this forward.
Philip, if I might bring you in here on this too, and to get this started, we're going to have a look at just what your opinion is here in terms of priority. It's taken quite a long time for hydrogen to come to the fore in this sense. But what would you say if you were giving advice out there right now? Where should a priority be?
Okay, prioritization needs to be done based on how much result you get for the subsidies, because this will be driven by governmental subsidies in the initial phase. And then I would think seasonal energy storage is certainly not the application where it is timely to put in subsidies. I think that's probably for around 2030 that becomes relevant. At the moment, we don't have enough renewable solar and wind power to store. I would focus on hydrogen production, of course, because that's where everything starts, but then linked to industrial processes, but because there you have the possibility with limited investment, provide a sort of a drop-in fuel, a replacement of brown hydrogen with green hydrogen, and get a significant emission reduction per dollar invested in that priority. That is probably not entirely the case in the transportation sector, where you also have to invest in refueling infrastructure and in cars, etc. So I think the biggest bang for the buck you probably get in industrial applications.
And of course, when we think about industrial applications, we really need to think about the amount of emissions that can be reduced there, and that's probably incredibly significant as well. Yukin, let me come to you, and also, thanks again for that presentation. But we're looking there in terms of where do you see the need for, a priority, or should there be a need? Are you agreeing with David there and thinking there's lots to do in every area?
I think there are. I mean, that part I'd agree in the sense that there is really a lot to do in every area, and also in leveling the playing field. I mean, obviously, hydrogen consumption or the value of hydrogen in different sector is worth a different amount in a sense, natural form. So if you look at, for example, in the transportation sector, because of fuel cell efficiency compared to, say, internal combustion engine, it is several times higher. So each calorie or MMBTU of hydrogen energy is worth a lot more in terms of miles compared to a vehicle. So in many places, especially in this part of the world, I mean, this is what the focus is in terms of the consumption. Then generation is also important, because transportation fuel is actually, transportation of hydrogen is, first of all, is in its infancy, and secondly, it is prohibitively expensive, and therefore a lot of times people are looking at producing hydrogen locally to be consumed locally, so as to level the cost, and so that it can sort of lower the subsidy if anything is required to level the playing field or promote its use. And at the same time, of course, distribution infrastructure and filling stations and this and that a market needs to be created in order for the production to come in. Production needs to go somewhere.
And maybe stay with this for a moment, because when you talk about a market being created, I mean, are we looking at putting supply out there or creating the market first? And, how does this play out? I heard somebody on a recent conversation talk to this about when, everybody gets on board in this, we're really looking at a major social transformation, that this is going to really, really change things. It's going to be a big sort of tipping point in the industry. But how do you create that demand?
Well, in time to come, I mean, hydrogen is transformative. I mean, it penetrates everywhere, and it has the potential. Um, I guess in terms of creating demand, I mean, if you look at natural demand, I mean, hydrogen is actually, has its niche in terms of, the, transportation sector where the mileage is very high. You need a long use, and you need a quick charge, and that's where hydrogen naturally went out. But then if you talk about buses and trucks and trains and things like that probably doesn't occupy a larger market. So in that sense, the promotion needs to be done such that it creates a better and a bigger market. And in some point, even if maybe partially brown or partially gray hydrogen can be used in order to create a market waiting for green hydrogen to come in. Suddenly, if you look at Japan, where they are looking at importing hydrogen, I mean, right now they have experimented with all three different types of transport: liquid hydrogen, ammonia, as well as liquid organic hydrogen carrier. I mean, they're doing all three.
Now, David, if I can bring you in here too, and when we think, we've talked about the international ambition, it's there, it's large, but how can we actually scale up? And as you said earlier too, it's not going to happen at the same level in different countries, in different regions, and for a variety of reasons as well. Interesting there, the observations from Yukin in terms of what's happening in Japan. But where do you see, I suppose, the best progress at the moment? Are we looking at the EU? Are you looking at Germany, Spain? Where do you see the most activity happening right now? David?
So what's happened over the last number of years is that Japan has been a leader for the last 30 years, probably in hydrogen, has started to be caught up by a number of other regions. So Korea is very, very aggressive. And the driver in Japan and Korea is partly about industry building. So it's about competitiveness in fuel cells, in hydrogen production, in other parts of the economy. It's also partly about energy independence. They import an enormous amount of the energy that they use today. It's fossil, and they're looking to diversify their supply sources and potentially long-term import hydrogen. So they're very aggressive on those parts. In terms of production, what we're seeing is Australia, Chile, places which have a lot of renewable energy, who could make green hydrogen and could export that to countries like Japan. And then on the policy side, I think we're seeing probably Europe really coming to the fore. So we've seen European Hydrogen Strategy, Clean Hydrogen Alliance, and announcements by the Netherlands, and by Portugal, and by Germany, you mentioned, by France, by others, about multi-billion euro subsidies, programs, investments. It's not all about throwing money at it. There is ways of creating demand, to come back to your original point, which are partly about CO2 emissions reduction, partly about extra credits, and partly also about air quality. So we're seeing zero emission zones being introduced into cities. If you're not allowed to drive a bus unless it's zero emission, you only have a choice between batteries and hydrogen, then you've already created a market, even if the cost is a little bit higher in the near term. And what we're seeing is buses, heavy-duty vehicles. There's a lot of activity going on, particularly in Europe on that front. So I think diversity, but all of these different drivers we need to take into account.
And I think we're probably going to see a lot more of activity go on as there's pressure, I think, too, on policymakers. And then just general, I think, pressure from consumers. And the governments and the even regional, local governments need to be seen to be actually taking action and doing something about it. Philip, when you look at the last few months, and here we are, the beginning of 2020, and some devastating effects on the industry around the world. But when we look at what's happened in terms of the reduction of CO2, and we hear all the stories about a cleaner, greener view, and the energy that's out there at the moment. Would you say that perhaps what's happened in the last few months will actually accelerate the creating that demand and actually be good for hydrogen demand?
Yes, indeed. I think what we have witnessed over the past couple of months, that we have seen an acceleration of inclusion of hydrogen policies into the recovery plans of member states, countries, and regions alike. And that is obviously very, very good news, because that was not what we expected in 2019, where we saw that there was a tipping point reached, especially at the EU policymakers level, where hydrogen was included into the Green Deal by the European Commission. But nobody expected that it would be at this point where it is today. And that is to a large extent because of the corona crisis and the inclusion of the hydrogen economy into the recovery plan. So that's, I think, is key. Now, with regard to creating demand for all these applications, I think it will be very, very important that policymakers really focus on why we are in this game. And that is not creating an export market for their own incumbent technology providers, etc. But we're in this game to reduce emissions. And that's why I think it's very important that going forward that these subsidies are attached to mechanisms that are driven by only one metric, and that is CO2 emissions and a CO2 tax. And that across all applications and across all countries and regions. Because otherwise, I think we are going to end up putting a lot of money into this sector without really attracting independent investors that want to develop projects.
Yes, and ultimately for the longevity of these projects, they have to stand alone, really. Subsidies probably fine at the minute, but everybody gets a little bit nervous when it comes to the S word, so to speak, and we don't like to be promoting it too much there. So it'll be interesting to see. I'm seeing some great questions come in, dear audience. Please continue to put them in. We'll get to them in a minute. But I would like to put another poll question out there because I think it's also vital to determine what kind of hydrogen we're looking at. It's not all created equal, so to speak. So in the event that, we're on board with this, I think that's a given. But what type of hydrogen, what kind of hydrogen, do we need to invest in today? So really have a think about this and have a look at that. And we heard a little bit there in terms of creating that demand. I mean, should we just be looking at green hydrogen, 100% renewable? And again, maybe we look at, a mix, a blend. We're looking at blue, perhaps, nuclear there, carbon capture and storage, brown hydrogen, all of the above. I mean, what do we need at the moment? So take a few seconds to digest that, to have a look and just think, what do you think we need to do right now? Because I think as we hear, many different countries are at different phases in terms of what they're going to do, what they are doing, how they're going to roll it out. But initially, what do we need to be doing? Where do we think is the investment? So if you have a think about that, and we'll close that poll in just a few seconds here, the way we can look at it and just feel what's on your mind, and then see from our dear panel out here where they're focused. They're all experts in this field, from an application point of view, as well as that, stronger academic point of view too. And David, I'm going to be really interested to hear what you'll have to say on that as well. But again, what do we need to do? So let's give it a few seconds there, and we get the results on that poll. Should we just be full steam ahead? And it looks like the general sentiment out there is go green, and really go green. But then a bit of a feeling that we need to be doing a little bit in everyone. Let me put it back to you, David, because do you think that go green is the only way right now? And is that where all the investments should be made? And is that where all the big focus should be made? But we do have a few people there saying we need to be doing a bit more. Obviously, the brown hydrogen, not in favor really at all. David.
So I think this reflects what Philip was saying, that we need really to have an underlying CO2 driver for everything that we do, and I'd very strongly support that. That's really the reason why we're here. So I think there does need to be an emphasis on green. The analysis that we do, though, suggests that if we are going to scale up as fast as we would like to, the ambitions are very, very aggressive out to 2025 and 2030, then we will probably have to do blue hydrogen as well. And there are two elements to that. One is that there is infrastructure that already exists. The second is that, of course, there are legacy industries that would quite like to be able to make a transition which is not a hard stop switch from, say, natural gas-based SMR to green hydrogen. So it does remain to be proven. I mean, there are very few SMR plus CCS plants. You actually need to scale those up significantly as well. So it's not a done deal. But I think anything that can reduce carbon is probably worth investing in the near term. In the long term, pure green.
Yes, and indeed we look at, the key players in the hydrocarbon industry at the moment, and particularly gas, talking about, of course, hydrogen, maybe in tandem as well. And if I can bring you in on this too, can gas and hydrogen, kind of do a dual path at the moment as we look towards, that renewable future that, without a doubt, when we look at the destination, I guess, the energy transition, we know where it's going, but it's not a straight road right now. What do you think in terms of the priorities and where that investment should be made? You can.
So, like I was mentioning in the earlier question, basically, and we do need to create the demand. I mean, we had recently done a project looking at, green hydrogen strategy for actually Singapore, the Prime Minister's office. Basically, I mean, there, what we are seeing is that, in countries, especially a lot of places in the Far East, where the, natural sort of renewable energy is not as developed. I mean, it is building up, but then the energy requirements requires a lot more, that there might be a place to really create the market in the application that is most suitable. We do need to have economies of scale. I mean, if you do bring in, like, for example, in whatever form, hydrogen, I mean, it needs to have a certain scale to be able to bring in, and therefore it needs a certain market. So in that sense, I would agree that in the long run, everything should be green and perhaps blue, if it depending on whether it's going to be carbon free or not. But in the transition, as long as there is a plan for an end date and how that can be transitioned over, and it is not a moving target, then perhaps there is a place for brown hydrogen to create the market. And again, we are looking at the ones that has I would say, the highest value of the energy to begin with.
Yes, and indeed, getting that end date in mind, I think that's a big ask in this industry at the moment here, because often I think people do their best to put the end date, and so many things can happen. But right, it's probably a good thing it's a great target to have in place, and it really does put a bit of pressure on people to make sure they get there. Philip, come in here and talk to us about this. What do you think? Should it be all or nothing, and we head towards that the greener, cleaner hydrogen future?
Yes, of course. That's what I would prefer, and I think it's feasible. I don't think that we need those big amounts of, let's say, blue hydrogen in the immediate years. I think we can cope with putting the assets for renewable electrolytic hydrogen in the various regions, etc. But I don't want to be stupidly against blue hydrogen, but I would attach to that that it should be carbon capture, storage, and utilization, only storage. Because then I think we create a similar issue as what we have with nuclear now, where the storage of the nuclear waste is a very big concern for humanity. Storing extremely high volumes of CO2 underground also I think will jeopardize safety in the decades to come. So storage and utilization, so reuse of the CO2 in the production of chemical compounds with the use of renewable hydrogen, yes, but simply storing it and hoping that no accidents will happen in the future, I don't think it's a smart idea.
Philippe, stay with me a minute because there's a few kind of questions. There was a question in there from Sam in Dubai from IBB talking about the safety aspects on that. So while you brought that up, Philippe, just stay with it at the moment. And indeed, follow up to the CCSU is that we have been talking about carbon capture and storage for years. And again, you know, it's the slow progress can be sometimes frustrating in terms of what's happening. So how do we escalate that, Philippe, and particularly when we look at the safety aspects as well?
Mm-hmm. Yes, of course. I think there are significant safety aspects around the use of hydrogen in various applications, not unlike the use of other very mundane, I think, in the meantime, gases such as natural gas, which is also not without any safety concerns. But what we have seen over the years is that when new technologies are being introduced, the safety standards always have been improved compared to older technologies where you very often the industry works with grandfathered in standards that are not of the same level as the ones developed for new technology and with new insights. So I'm quite sure the industry can deal with that and be able to develop technologies and infrastructure for hydrogen that are safe. The main concern, of course, is in storage and storage under pressure. And there are already very safe approved solutions for that. We only need to make sure that when we scale them up, it is done in a very vigilant way.
Okay.
Yeah, thank you on that. Yeah, forgive me, we're having a little bit of a technical interference there, but I hope everybody at home can hear us clearly. David, if I can come to you when we look at, and you had even said there, you know, there's going to be different projects out there, some of them large scale, some of them not. And we have a question here from Toyin Oyewole talking about what is the cheapest small scale technology out there?
There's a very interesting mix of technologies. So Philips' company now has very good electrolyzer technologies which can be used at small scale, and they're all in industrial applications. There are also small-scale production units which can use natural gas, for example, steam methane reforming. So there are 300,000 fuel cells distributed in apartment buildings in Japan, which have a small-scale reformer, which produces hydrogen. The costs are very different in different places. It depends on exactly what the requirements are, and there's still development required because what we see is, you know, even 300,000 units is actually a very small number in terms of industrial production. So it's a big mix. I think we'll see a variety of electrolyzer technologies. We're likely to see some novel technologies, so photoelectrochemical, biological production of hydrogen. There are many things going on in labs worldwide, which I think show great promise for the future. But in the near term, electrolyzers for small-scale green hydrogen are definitely the way to go.
And indeed, a follow-up question on this was for Philippe, though, this time coming from Sandru Dada here. A question, Philippe, with electrolyzer process, what do you do with the O2?
If you don't have any use for it, you simply vent it. It's completely harmless, and we all need oxygen, of course, to survive. But very often, when an electrolyzer in large scale then is sited in an industrial estate, there are over-the-fence neighbors that probably can use the oxygen in their industrial processes. So it can be an additional value stream for an investor in a large-scale electrolyzer facility.
And that's probably what a lot of companies, particularly in large scale, I think industrial processes, would like to be doing because they really want to get the great value out of this. When we look at hydrogen, a question here from Sean Keenan. Does hydrogen need to beat batteries in terms of cost and efficiency if it is to be widely adapted, or for the moment, can we work together? What do you think, Yukin?
Well, definitely there's room for them to work together. In terms of applications, like what I mentioned before, hydrogen is, with sufficient filling station, hydrogen vehicle would just need to go into the filling station, fill up. It takes a few minutes maybe just to, and then you're fully good to go for a few hundred kilometers. Whereas batteries would take at least half an hour, even in the fastest fast charge. So in that sense, that in itself is a technology comparison that gives you a niche on hydrogen vehicles, even on the comfort level, and also not having the sort of mileage anxiety as the miles run down and you can't find another recharge location. That's one aspect of it. Now, of course, the other aspect is for the vehicles such as buses and taxis and all the other applications that requires freight, for example, that use a lot of that are used many hours in the day and really don't have time to wait for a recharge. So in that sense, naturally there is some sort of a tendency, but obviously it also really depends on infrastructure, in the sense that if a country has really committed a lot of money in terms of battery filling technology, then to double it up and do a hydrogen one would require some thinking about it, especially you don't know whether the volume is there or not.
If I might follow up a question for you, since you're looking after Asia and the Middle East region, to a question from Asif Masood, asking if there are any updates and progress on green hydrogen in terms of what's happening in the Middle East region. Yukin.
Wow.
I think there's a lot of talk about it and a lot of projects that are beginning to happen, and they're definitely looking at it. But maybe you can enlighten us.
Actually, in terms of projects, I mean, honestly, I don't really follow too much on the specific projects. I mean, I do have the opportunity of people coming to us to look at things like green ammonia and production of green hydrogen and on an evaluation basis. But I don't think I mean there must be announced ones, but I'm not that sure. Sorry.
Yeah, I mean, I do. Any of David, are you looking at this region too? I know there's certainly tremendous talk about it, without a doubt, and I know there's definitely great research going on here in the region as well. But actual projects, I don't know, Asif, if we're going to be able to give you that answer you want. David, anything?
There is a lot of enthusiasm in the Middle East. There's one of the world's biggest hydrogen projects, which has just been announced in Saudi Arabia, which is in the NEOM new city, which is looking at producing an enormous amount of green hydrogen and using that in ammonia production. But there is also enthusiasm throughout Oman, throughout Emirates, throughout other areas, partly because of the ability to harness some of the solar power. So there is a consideration that perhaps in the future hydrogen will be an exportable commodity with high value. And so there is a consideration about how to go about developing local industry. I know we've seen a lot of policy moves which are looking to build sustainable industries post oil and gas, whether that be digital economy, whether that be high value manufacturing and other things. And hydrogen plays very strongly into that. So there's definite interest in the Middle East, and there's definitely projects going on.
Yes, and I mean, we hear a lot of it, particularly here in the UAE. I'm based in Dubai here, so it's like I think the appetite, to make sure that they're heading in that right direction is fascinating. Staying with sort of the Middle East, when we think some of the biggest oil producers here in the region, a question coming from Sohail Zubain, and maybe if I can have Philippe, if you can look at this one first for me. yes, basically saying that, everybody is looking in this direction. But if we look at further dips on the price of fossil fuel, obviously the price of oil and gas been very low there. Is there, from a commercial standpoint, a danger that they might actually edge out all kinds of renewables, and especially green hydrogen, because the price is so uncompetitive at the moment? So when we're looking at this lower for longer oil price and the low gas price at the moment, is there still room, for the higher priced renewables to actually compete in this market? What do you think, Philip?
Definitely. I think oil price is not a metric that will drive the energy transition. To restate it, I think we're all in the game here to save the planet, and a number of things and technologies need to get introduced and replace polluting and fossil-based technologies over the next decades. We have started with wind, solar, hydropower. Now we need to convert and store that green power with battery technologies and with hydrogen, so that we have in the form of green hydrogen a chemical form of energy that we can use in large-scale industries and in transportation sectors, etc. So that will be driving the introduction of green hydrogen technology in the world, and the driver will be CO2 emission reductions and CO2 tax. We are not there yet. The minds are not completely ready, but you can see the policymakers converging to that same conclusion. And then it's not the oil or the gas price that will drive transition, but the cost of CO2 emissions.
Different narrative coming from the big international oil companies too, and they're talking about becoming net zero, and they're changing their business plan, and they're really looking at a big shift, and they're doing that obviously in response to, I think, international sentiment around the world. So we have to take all of those things into effect as well. You can come in on this next question for me, and indeed I think it's something that I'd like to hear from all of you, because when we look at it, and this is from Barry Gallant here. Barry sends a question in: can the implementation of green hydrogen projects be accomplished without government incentives? And we talked a little bit about subsidies, and we're talking about the policymaker. Is there a possibility that anybody can go it alone and projects like this can be profitable without government incentives and subsidies? What do you think, Yukin? I'll come to both of you afterwards.
Well, in a nutshell, it needs something to kickstart. So if I were to look at, for example, the solar and the wind installation and technology. I mean, today, both technologies do not require subsidy, but the hydrogen will take some time to get to that point. Eventually, hopefully, it will. I mean, like I said, there is a few differences in the sense of production and usage of hydrogen locally can probably happen first, and they'll probably cross the threshold earlier, and then transportation would definitely require slightly longer. What I meant there is like long haul transportation, seaborne transportation of import of hydrogen energy.
David, coming on that, I suppose, carry on from it in many ways to how can hydrogen be more competitive from the supply chain perspective, particularly storage, transportation, and indeed, the distribution. How is that going to happen too, in terms of the pipelines for inland transportation? That's a question that comes from Osman Khan. David, if you can address that.
Yes, happy to. I'll sort of lead on from what Yukin was just saying, because I think what we're seeing is we're already seeing a move towards investments in very large-scale hydrogen projects on the back of low-cost renewables. And in fact, the cost of an electrolyzer, and I'm sure Philip will be happy to tell you in great detail at some point, it can be very low if you order enough of them. So there's no intrinsic problem there with cost. It's really just about making sure that you have an agreement in place for an industrial offtake, and then people will be very happy to build gigawatts of renewable hydrogen facilities. there is an important point about how you move it on. And so the initial offtake agreements are likely to be these industrial products like ammonia. So you already put hydrogen into ammonia, putting it into green ammonia gives you an immediate and relatively cost-effective way of transporting it and introducing it into the energy system, fertilizers, agriculture, whatever. What needs to happen in the intervening time is improvements and tests and projects which are already starting on other transport mechanisms. So we're starting to see hydrogen blending into existing natural gas pipelines. We've seen a lot of developments in Europe along those lines. And in fact, a big demand for hydrogen, if all you want to do is produce hydrogen at large scale and start to introduce it into the energy system, blend it 5% with natural gas in the pipeline. Doesn't have any negative impact on the pipeline or on any of the appliances, and it would use a lot of hydrogen. So it gives you a demand creation in a sense. It's not a high value use, but it is an important use. And equally, people are improving storage technologies. People are improving ways of transporting hydrogen long scale. You can mention the Japanese. There's a project, Brunei, shipping hydrogen in a liquid form, in a liquid organic hydrogen carrier all the way to Japan. There's a project which is looking at transporting liquefied hydrogen, so minus 253 degrees Celsius, from Australia to Japan. So these projects are nascent technologies, but they're going to be very important for a post-2030 tradable, fungible commodity, which I think is what will be a very, very exciting place to be.
Indeed, and as you said, once that demand is there, once the market is there, the players are on board, the technology is on board, and people are going to make sure that it's done, in the most efficient, the most safe, and ultimately, in the longer term, the most profitable way, without a doubt. Philip, come back in, and I loved what David mentioned there to get you talking more about the electrolyzers. And once I believe the electrolyzers had been described as the rock star of the energy transition, but you don't necessarily agree there, sort of. Talk to me about in terms of costs and what is the electrolyzer space, so to speak?
Yeah, I think the importance of the cost of the electrolyzer has been overplayed for many years. I think when you look at the business case of a sizable electrolyzers investment, then you quickly notice that it's the electricity price that determines your business case. So 70 to 80% of your business case is driven by the electricity cost. And there we have an issue, and that's not something that a company like Nel or our peers can solve. Policymakers will have to address that, because in our electricity bill, if you look at it, whether you're a small or a bigger company or an individual household, 70% to 80% of your bill is taxes, levies, transportation fees, etc. And that is killing the business case. So policymakers will have to find a solution for this issue and grant to a certain extent full or partial waiving those taxes for renewable hydrogen production. Otherwise, it will be very difficult for business cases to emerge. So the rock stars, I think, in general, for the renewable hydrogen market is not the electrolyzer technology providers or other companies, but it's actually the policymakers. They can make things rock. If they want it, they can get it, but they have to stand up and get it done.
I feel a new song coming out of this one here, but it's like you can get it if you really want it, so to speak. And again, it brings the entire industry, I think, into this dialogue and how important it is. We don't have time for much more questions. I'm going to throw one out there. In fact, we've only got about 6 minutes here, and something I think that you can all maybe as a closing point here, because there's a question coming in from Asif Masood. Thanks again, Asif. You've been very good here in keeping us engaged. And from Richard Kale, there we have a shout out for Scotland, for Aberdeen, whereby they've been running their buses for several years now. So we're seeing some great initiatives coming out of many cities, indeed, around the world, running buses on H2 that has actually made such a big difference. But a question I'd like to maybe wrap it all up with the three of you, when we look at green hydrogen implementation sort of down the road, and how do you see this in the next, say, 5 to 10 years? So they're putting a time limit on there. So Asif, if I can, thank you for that question. And David, perhaps if I can start with you.
So I'm very positive. I think, as Philippe says, there's a question about electricity pricing. But to be honest, a lot of what we're seeing is very large-scale plans which are sort of off-grid in a sense. So it's potentially making and using your own electricity. We've seen the announcements, so 2 gigawatts of electrolyzers planned for Portugal, 40 gigawatts for the whole of Europe. We've seen Australia looking at putting in place real projects which are of the order of 10 to 20 gigawatts. These are enormous projects. And these are projects that are going through engineering analysis, first investment questions, they're doing the groundwork. So I think it will inevitably take a couple of years before we see, real scale. We're seeing 20 and 30 megawatt projects already being built in the pipeline. But I think it'll take off very, very rapidly to 2025 and then exponentially to 2030. I'm extremely positive.
And that's good to hear. What's your predictions for the future? Give us that timeline, 5 to 10 years, and we've only got a short time to answer this question, so bear with me. Thank you.
Actually, for me, I'm thinking that a lot of development probably will happen more locally rather than internationally. So Australia has a project that has many projects in terms of gearing for export. They have said that by 2030 you get a few million of external demand for export market being out there. That is something that could happen. But what I would looking at is more like, if you look at the EU market, it's basically they have developed policies in place and systems and investments and timelines basically surrounding this region. So large regions like this, if you look at China, the same thing, a lot has been in sort of transportation, pilot projects, etc. That also wants to penetrate. So large homogeneous markets is probably where I would see it happening first in the next 5 years, let's say, before international transportation of hydrogen fuel.
Philip, I'm going to give you the closing word on this, and apologies to all my dear viewers at home, we didn't get all those questions in. Nikita has put in one there also talking about investment here. So the need for investment, and when we look at hydrogen and its great advantages compared to nuclear, to wind, to all of that. A closing word from you, Philippe.
Yeah, the only thing I would like to advise everyone is to relax, sit back. It's going to happen no matter what. It's very simple. Climate change is a fact, and renewable hydrogen technology is the bridge between renewable power and renewable fuel, renewable chemicals. So there's no way around it. It will happen.
And on that very certain note coming from you too, and again, for all of you involved in this, you're there day to day, you know what's happening, you know the demand that's coming from your clients, you know the demand that's coming from industry. And as you said too, looking at what's happening with the policymakers, we're beginning to hear and to live, I think, a very, very different narrative than we did even 5 years ago. So what can happen in 5 more years to come, really, as you said, just watch this space, because it's definitely where I think it has begun, and without a doubt, it's going to continue on that. So, I mean, an hour has just flown, gentlemen. I just want to thank the three of you and thank you for your input. We will have this entire recording available to everybody at home, and I know you just look at our colleagues here, look at Nel Hydrogen, look at E4Tech, and also at Argus, the great work that they're doing there in this space, and a lot, of course, great information coming from all of you. So I want to thank Yo-Yu Kim, Professor David Hart, and Philippe Schmidt. Thank you all so much for being with us. It's really, I've learned a lot, and I hope our people out there have learned a lot as well. So gentlemen, it's been a joy. Thanks so much.